With that, we can plunge into the first presentation. Elizabeth talking about the TEAL plugin.
Good morning, everybody. I'm Elizabeth. I own TEAL, and so you can come to me with any questions you have about it. And I just wanted to present uh, a summary of what is TEAL and the financial basics of what it calculates, because I don't want to assume that anybody here has any background in finance whatsoever, and then talk about how TEAL works as far as the components and cash flows that you build in it. And then I have two examples to show the broad capabilities of TEAL and what you can use it for. So TEAL is the tool for economic analysis. It's a Raven plugin, and it calculates characteristics of cash flows like net present value. And it's a useful behind the scenes part of Heron. You've probably heard it said a few times, but it can be helpful as an independent tool if you know how to use it. And the calculations are based on components and then cash flows that you put into each component. And you can use it for static calculations, or you can use it for parametric studies if your cases aren't time dependent. The first thing that TEAL calculates is the net present value, and that is the value of future money. It's based on the time value of money, and it's used to determine the long-term value of an investment. So this is based on a discount rate, and there's the formula for NPV there, and then a diagram that kind of shows what it is. But essentially, cash that you earn in the future is not worth as much in the present. So you use the NPV to figure out if an investment is going to be profitable in the future. So if your NPV is less than zero or greater than zero, it means that you're going to have a positive return. If it's equals zero, that means you're basically going to break even. And then if it's less than zero, then your investment's going to have a negative return. And the next characteristic that it calculates is the internal rate of return, and that is the discount rate as which the NPV equals zero. And the discount rate it's a lot of times just referred to as the interest rate, but it also can take into account costs associated with like inflation and such, although you can add that in separately in TEAL. And it's used for comparison of prospective investment options. So if you have a higher internal rate of return, there's a higher expected growth rate. And then there's just a chart there that kind of shows what it is. And the probability index is the ratio of the future cash flows to the initial investment. And so you want a PI of greater than 1 so that your future cash flows are more than your initial investment. So it sort of is like, tells you kind of like what the NPV tells you, but a little bit different calculation. And then the last thing you can do with TEAL is an NPV search. So kind of like in Excel, when you do a goal seek, this is kind of what it does. It finds your the multiplier that makes your NPV whatever the target is. And then you can use the NPV search to search for an IRR or a PI. You just have to set the discount rate to your IRR and do an NPV search of 0. And then if you want to do PI search, you do an NPV search where your target PI is multiplied by your initial investment. So this is the formula and shows that X is the multiplier that you're going to find. So how TEAL works is you have in the XML format, you have a block that's your global variables, and this basically contains all the components that are all the attributes that are applied to all the components, but it also contains a list of your cash flows that's going to be sent to Raven. So you need to put all of your cash flows in the indicator block, because otherwise Raven won't know that your cash flow is there, and it might not be included in your final calculation. And so you say what you want, IRR, NPV search, NPV, it can calculate all of them at the same time. And then put in a discount rate, you can put in a tax rate, inflation rate, and then your project time, which if you want to set a specific amount of time for your project, like 60 years, that you want to be sort of global for all components, then you can put that in there too. But yeah, the most important part is this indicator that you want to make sure that you put your component and the name of each cash flow separately there so that it will be included in the calculations. And then when you do your component definition, all the cash flows are contained within your components, and that can be something material like a power plant or a turbine, or it can be non-material like an electric market. And you can have unlimited components and unlimited cash flows. So your NPV, your PI, and your IRR are computed for the least common multiple of all the component lifetimes, unless you specify a project length. So if you have a component that has a life of 10 years and a component that has a life of 25 years, then your component one is going to be rebuilt several times until it reaches that, until the 25 years is going to be built again, because then you're still going to have time left on your first component. So then it's going to be all rebuilt for 50 years. But if you set the project length to 25 years, then component one will just be rebuilt once. And then component two won't be rebuilt because the project will end at the end of the life of component two. And you can also specify a start time for a component, like if you don't want it to start until 10 years into the project, or you want to specify a number of rebuilds before it stops, you can specify that as well. And also, if you want a specific tax rate or inflation rate for a certain component, you can do that in your component blocks as well. So your cash flows are within your component blocks, and there's two kinds of cash flows that you TEAL. One is CapEx cash flow, so your capital expenditure, and that is applied only when the component is built. So that's at the beginning, and also anytime the component is rebuilt, it's going to apply that cash flow again. And so and then there's also the recurring cash flow, which is applied at every time step, which is typically a year, but depending on how you want to set it up, you could make it every month or so, because the TEAL and Raven are both agnostic to units, so you can do whatever you need to do there. But the formula for the cash flow has a multiplier, an alpha, a driver, a reference, and then X, a scaling factor. And I'm going to go into more about what these are, but essentially your driver is a variable that's driving your cash flows, like like the size of a power plant. So if you want the size of the power plant to be the driver, then your reference would be the size of a power plant that you know the cost of, and that would be your multiplier alpha related to the reference value. And then X is your scaling factor. And then there's an optional multiplier you can have as well, and that generates your cash flow there. I don't want to spend too much time talking about Raven because a lot of this is in the Raven manual, but I just wanted to talk a little bit about how TEAL interacts with Raven. So when you go into your Raven file, you're going to list all of your drivers and all of your variables that are going to be sent into Raven. And then also you need to add TEAL as an external model to Raven. And then you can also use, so when you are setting up your variables and you want to add and specify what they're supposed to be, you can use custom functions, or you can make it a constant, or you can do a distribution, like if you want just a uniform distribution to test between these two values. And you can do all of that in the sampler in Raven. So the first example I have is just a single point calculation. So if you wanted to build a nuclear plant at just 500 megawatts capacity, and you know the cost of a 1 gigawatt plant and a scaling factor, and you know the fixed costs and the variable costs, and you know the capacity and the number of years. And then we're going to just set a average yearly electricity price of $35 per megawatt hour because, like I said, this isn't time dependent. And then we're going to have rate of 5%. So you want to make sure that you normalize your units. So if you want to use megawatts, that's fine. You can use gigawatts, you can use kilowatts. Just make sure that everything is normalized. And so this is what your TEAL cash flow looks like in a very basic sense. So you have your component, which is a nuclear plant, your CapEx cash flow, which contains your driver, which is the capacity of the plant, And then you have your reference of 1 gigawatt and a scaling factor. And then you have your recurring, a fixed cash flow, which is your driver is also the plant capacity because it's based on the megawatts of the plant. And then your alpha is that $1,000 per megawatt. And then you have a second recurring cash flow, which is your variable costs, which is the number of megawatt hours that the plant runs. And then the $20 per megawatt hour variable costs. And then your second component would be the electric grid. And this can be a recurring cost. And your driver is going to be the same megawatt hours that the power plant runs. It's going to sell everything that it makes to the grid. And then your alpha is the price of electricity. So when you put that into TEAL and you go over to Raven, so Raven is going to handle the functions and the sampling of the calculations, and then TEAL is going to handle the actual cash flow calculations. So you're going to make your capacity a fixed variable or a fixed of 500 megawatts, and then also your load hours, is 500 megawatts times the number of hours in a year times your capacity, and that gives you the number of megawatt hours that your plant's running. And so when you put it through TEAL, you're going to get a NPV of about $600 million and internal rate of return of 0.106 and your PI of 1.013. So it's greater than 1, so you have a good investment, I guess, and the internal rate of return is greater than your discount rate, and that's also good. So the second example that I have is more complicated and showing a bit more of the capabilities of what you can do. So if you want to optimize power plants based on a load curve that you have, you can take this load curve and import it into TEAL or import it into Raven using functions and determine a best mix of power plants for the NPV. So I have a load curve here with a maximum demand of 2,610 megawatts, and so that's the size of the system, and then our electricity price is $35 per megawatt hour. So there's 3 components here. You have a coal plant, a nuclear plant, electric grid. I made up all these numbers, so don't cite me on this. And so the cash flow for your coal plant, you're going to have a capital cost, a recurring cost that's fixed, and a recurring cost that's variable. So just like we did before, this time I just have the reference as 1 megawatt, and so the alpha is just the cost of 1 megawatt with a scaling factor of 1. And then the same for the nuclear plant. And the nuclear plant, we're only going to have a recurring fixed cost of the $28 per megawatt hour at 95% capacity. And so then you also have a third, which is the electric grid, and that's going to have a recurring cost of the sales. So you have your demand, which is the number of hours that are under that demand curve, and then $35 per megawatt hour. So now when we're interacting with Raven, it's a little more complicated because some of our variables depend on each other. So this is a optimization problem. So we're going to do a Monte Carlo sampler with a uniform distribution of 0 to 2,610 megawatts for the coal plant. And then there's a function that calculates the size of the nuclear plant that just takes the whatever capacity is set for the coal plant and subtracts it from the maximum capacity, and that is the size of the nuclear plant. And then for the operating hours, if we know the capacity of the coal plant, I wrote a function that takes the integral under the curve of the area minus where the nuclear plant would be, because the nuclear plant's going to be running at, it's going to take the base of the curve probably because it's the one that runs at 95% capacity and doesn't have variable costs. So it just takes the area under the curve of what's left after the nuclear plant meets it. And then for the electric grid, I have the demand, that's the full number of hours under the curve, and then the price of electricity. So once again, I just wanted to touch a little bit on the custom functions. So it's not as hard as it seems. It's really basic just with Python functions. And then your Raven input contains your variables that you want in and the name of the function, and it calculates it for you. And there's details on how to do this in the Raven manual as well. But it is pretty easy. Like this one, I just have the function that subtracts the nuclear or the coal capacity from the nuclear capacity, and it can be as simple as that. So when I put this through TEAL, that's the graph of the designs that I get for the coal capacity versus the NPV. So obviously this is a very bad investment. I don't recommend anyone do that. But the optimal design is around 1,000 megawatts for the coal plant. And so, and you can also, if you wanted to hone in on what the actual optimal design was, you could just go between like the two designs up there are 912 and 1064. You can just do a optimization between those 2 points and get better resolution. But also, I bring this up too because you can add a secondary market other than just your electric market as well. So I've added like a hydrogen market that figures out how much time the nuclear plant is running but not selling. And then I take those megawatt hours and make that as generating hydrogen and selling hydrogen. You could also figure out what carbon dioxide the plant is producing and figure out like the price of coal capture and storage based on that. So it's very versatile, a lot more than it seems at first glance, and can be really useful for those kinds of problems. So I think TEAL is an underrated tool. It requires really only basic knowledge of Raven. And once I make a Raven code for my cash fill problems, a lot of times I can use the same one over and over again, just changing the things that I need to change. So you don't need to write a whole thing from scratch every time. It's great for this just single calculations, or if you have a non-time dependent analysis. Also, I think that the custom function aspect is a little bit of intuitive because you just think about it like a variable problem and put in your functions. And then it makes it easy to do a parametric study like I showed you before. So, and with that, I will take questions.
Thank you, Elizabeth.
Oh yeah, so I see a question in the chat box. To model time-dependent cash flows, you can do that in Heron. So TEAL is the tool used to calculate the cash flows that Heron does, and Heron uses the time dependencies. So you can do that there.
Okay, thank you. Is there any other questions for Elizabeth? I don't see anything. Okay, so I have a question. So it is an open source tool, right? So where can I get it, and then how do I install it? Does it just integrate with Raven, or is it installed together with Raven? You elaborate on that.
Yeah, it's installed together with Raven when you're going through the Raven installation process. That when you're installing your plugins, you want to install TEAL as a plugin, and so that will just bring it up and it'll be in your plugins folder in Raven. But yes, the instructions are in the Raven installation instructions. Just once you get to the part where it says install plugins, then click there and it'll tell you how to install TEAL.
Okay, thank you very much.
So quick question, Elizabeth. Can you hear me?
Mm-hmm.
Yes,
my question is kind of fundamental. So the discount rate is always something that is uncertain. This takes the whole TEAL platform into the realm of stochasticity. In other words, how does it address instances where specific parameters are uncertain? Thank you.
Yeah, I guess with the parametric studies, that's kind of where you can do an uncertainty analysis, because it's not it's not time dependencies or anything. But like with the discount rate, I have not figured out quite yet how to make the discount rate variable. I've been trying that actually. But you could just run multiple calculations with the same variables but different discount rates and just pull those together, and you can look at that. But that's pretty much how it can handle uncertainty.
Thank you very much.